Hello everyone and welcome to the OneClass channel. My name is Donna Riel and I'm a recent master's graduate from the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. So now let's just get started on our set of questions for today's session. Okay, so question 1, you can see has 4 different parts to it. The first part asks, what is the empirical formula of naphthalene? Part 2, the empirical formula of acetic acid is CH2O. If its molar mass is 60.05, what is the molecular formula? Part 3 is also looking for its empirical and molecular formulas. And lastly, we are given percent compositions of both carbon and hydrogen. And then we just need to find its empirical formula. Okay, so let's just tackle all the different questions one by one. So part A is pretty easy. What is the empirical formula of naphthalene? Okay, so let's just write down the definition of empirical formula in case you didn't know what it meant. Okay, so empirical formula is basically just the simplest ratio of atoms. So the opposite of the empirical formula would just be the molecular formula. So in the case of naphthalene, the molecular formula is C10H8. So if we wanted to find its empirical formula, we would just need to write C10H8 into the simplest ratio. So notice that both 10 and 8 are divisible by 2. So the empirical formula would just be C5H4. And that is the answer to the first part of question 1. So the second part gives us the empirical formula, CH2O. And it also gives us the molar mass, which is 60.05 grams per mole. What is the molecular formula of acetic acid? So we can break this up into different steps. So step 1 is to find the mass of your empirical formula. So if we know the mass of our empirical formula, we can find out its ratio with the molar mass that's given, and then we'll know whether or not, like how to multiply in order to get our molecular formula. So first, we need to find the empirical formula mass. So the empirical formula is CH2O, and I just denoted it as a capital M, like molar, like as if we're finding the molar mass of CH2O. So it would be the molar mass of carbon plus 2 times the molar mass of hydrogen plus the molar mass of oxygen. So the molar mass of carbon, so these values are just found on the periodic table, and it is 12.01 grams per mole. For hydrogen, it's 1.01 grams per mole. And for oxygen, it's 15.99 grams per mole. So the empirical formula mass is 30.02. Okay, so step 2 in answering this question, what did I just say? Answering this question is to find the ratio between the empirical formula mass and the actual molar mass, which is 60.05. So let me just show that I'm going to divide our actual by our empirical. Actually, I'll write this as molecular over empirical. So the actual molar mass was 60.05. And the empirical formula mass is 30.02. So when we find the ratio, we want to just round to the nearest whole number. So in this case, it would just be 2. So now for step 3, we just need to multiply by the ratio. So our empirical formula mass was CH2O. Multiplying this whole thing by 2 gives us C10H8O2. And then this is our molecular formula. Okay, so that is part B of the first question. So I'm going to start a new page and do part C. Isoprene is a liquid compound that can be polymerized to form natural rubber. It is composed of 88.17% carbon and 11.83% hydrogen. Its molar mass is 68.11 grams per mole. What are its empirical and molecular formulas? So this is pretty much taking what we already know, and it makes it a little bit more difficult. But again, I'll just break it down into different steps. So step 1, since they give us the percent composition of the sample, the first thing I like to do is to assume we have 100 grams of sample of isoprene. So this makes it easy for us to convert from percentages to grams. So if we had 88.17% of a 100 gram sample of isoprene, this gives us a mass of carbon to be equal to also 88.17 grams. And similarly with hydrogen, this gives us 11.83 grams. Okay, so now that we have the masses, the second step is to find the number of moles. So let's recall the equation for number of moles is mass over molar mass. So first, let's look at the carbon. Its mass was 88.17 grams. And the molar mass of carbon is 12.01 grams per mole. Okay, so the number of moles of carbon is 7.3. So now let's do the same thing for hydrogen. Its mass is 11.83 grams, and the molar mass of hydrogen is 1.01 grams per mole. So this gives us number of moles equal to 11.8. Okay, so now that we have the number of moles of both, we want to divide by the smallest. So our smallest value was 7.3, and that is for carbon. So let me just show here that we divide both values by 7.3. And then when you divide 11.8 by 7.3, we are just going to round to the nearest whole number, and we end up with C10H8. So this is our empirical formula. So that answers the first part. We can also just, we don't even have to write the 1. It'll just be CH2. Okay, so the question also asks for the molecular formula of isoprene. So this brings us to step 4, which is to just find the empirical formula mass. So now this is similar to the previous part of this question. So I'm just going to write molar mass of CH2 is equal to 12.01 plus 2 times 1.01, and its mass is around 14.03. Okay, so now let's look at its actual molar mass, which is 68.11. So now we just have to find the ratio. So 68.11 divided by 14.03. Again, we want to round to the nearest whole number, which is 5. So now, if we multiply our empirical formula by 5, we end up with C5H10. Okay, so CH2 was our empirical, and then C5H10 is our molecular. And now let's answer part D. I'll also start a new page again. Camphor is found in camphor wood, much prized for its wonderful odor. It is composed of 78.90 grams of carbon and 10.59% hydrogen. The remainder is oxygen. What is its empirical formula? This is similar to the previous part, but they need us to find the percentage of camphor that is oxygen. So step 1 is to again assume 100 grams of camphor. If 78.9% of camphor is carbon, then the mass of carbon in 100 grams is 78.90 grams. And the mass of hydrogen is 10.59 grams. This means that the mass of oxygen is equal to 100 grams, subtract 78.9, and then subtract 10.59 grams. And this gives us the mass of oxygen, which is 10.51. Okay, so now we have the masses of all of our atoms. Now we have to find the number of moles. For carbon, it is 78.9 divided by 12.01. Okay, so this gives us 6.57. For hydrogen, it's 10.59 divided by 1.01. And you end up getting 10.48. And then lastly for oxygen, 10.51 grams divided by the molar mass of oxygen, which is 15.99. So this will give us 0.65. Okay, so now that we have the number of moles of all of them, we want to divide by the lowest number of moles. So let's show C. So the lowest number was 0.65 moles. So for carbon, it's going to be 6.57 divided by 0.65. For hydrogen, it's 10.48 divided by 0.65. And then for oxygen, it's just 0.65 divided by 0.65. Okay, so again, we're going to take all the different fractions and convert it to the nearest whole number. And we end up getting C10H8 and then O. And this is our empirical mass. Okay, so that's where this question ends up, because they don't ask for molecular, nor do they give us the molar mass of camphor. So this question is done. And now we can compare our answer with the junior tutor. So starting all the way back to part 1A, the empirical formula of a compound gives the simplest ratio of the number of different atoms present, whereas the molecular formula gives the actual number of each different atom present in a molecule. Dividing the subscripts by 2, the empirical formula of C10H8 is C5H4. Okay, so part 1 is correct. To determine the molecular formula given the empirical formula, first divide the molar mass of the compound by the empirical formula mass. The result should be a whole number or very close to a whole number. Then multiply all the subscripts in the empirical formula by the whole number found previously. The result is the molecular formula. So they found the empirical formula mass to be 30.026. Dividing it by the molecular, you get 2. And then they found their molecular formula to be C10H8. Okay, so part 2 is correct. Part 3, first find the empirical formula by doing the following. Get the mass of each element by assuming a certain overall mass for the sample. And then they say 100 grams is a good mass to assume when working with percentages. Okay, so then they just showed how you would get the masses. They got 88.17 grams and 11.83 grams. Convert the mass of each to moles, so 7.3 and 11.73. Divide each by the smallest value to get the subscripts. So here they showed that when you divide, you get 1.6, but then they round to the nearest whole number, which is 2. And then they found the empirical formula, which is CH2. To get the molecular formula, determine the mass of the empirical unit. So it was 14.03. Next, determine how many empirical units are present in the molecular unit. So again, they got around 4.856, but then they rounded it to 5. And they found their molecular formula to be C5H10. And now let's look at the last part. Similar process as in number 3 to be carried out. Okay, so they showed how to find all the number of moles. For carbon, 6.57, hydrogen, 10.5-ish, and then for oxygen, 0.65. Dividing by the smaller value, we get 10, 16, and 1, and their empirical formula is C10H16O. Yep, so this solution is correct. Okay, so that was a long multi-question question number 1.